All right. Hello, everyone. So we are getting started on our session for today. We'll wait for a few minutes for folks to join. So Aniket and I are on the call now. So we will wait for the folks to join. Folks who are in the session, please feel free to add uh, your name, your uh, what do you do? Are you from product management? Okay, I think we can get started, Aniket. Yeah, do you want to go in the slide mode? Yeah.
Yeah.
Can anybody put a comment saying that they are able to hear us so that Aniket and I can get started?
And see the screen as well if they can confirm.
Yes. Can one of the participants please put in the comment on the chat? I'm not sure if we have any issues getting started. I think we will get. Yes, okay. I hear Nitika saying yes. Thank you guys for confirming. This is we are also using the LinkedIn Live and StreamYard for the first time. So thank you for supporting us over here. All right. So I'm super glad to host Aniket yet again. Aniket and I did a session a few months back on AI for product management, and we received a lot of love. So we'll share a little bit more details on that. So today, what we are going to talk about, and I know that Gen AI is like the buzzword today, right? Everybody, every company, whether irrespective of the size they are definitely doing something around Gen AI. Whether it could be just looking at how to, streamline or optimize their internal use cases, or is there an opportunity to leverage GenAI to make a new revenue stream, improvise on the current product? So while there is so much of buzz around that, we are kind of going to divide this uh, meet up today on two parts. One is that largely what is some of the reports I just kind of brought together, a McKinsey report and a HFS report. What are they saying? And then what we are going to do is that Aniket is going to pick up one use case, and he's actually going to just peel it down like a layers of the onion to say that how was it done in a non-AI world? How has the Gen AI kind of given us a lot of new tools? How do you go about doing that? So without any further delay, Aniket, if you can go on to the slide number 2, we will probably start with a very brief introduction. That's me, and I host a podcast called as Product Talk with Malti, and super glad to be doing this under that banner. And I'm also a fractional CPO, and pretty much all the 24 years of my work experience has been building software products. So now I'm in the other side of the career where I'm trying to teach product management at B schools with corporates and continue to be a practitioner and a learner by learning from some of my other peers in the industry. And would highly recommend you to sign up for the Product Talk with Malti, wherein I bring in a lot of founders and product leaders and share their successes, failures, journeys, learnings from building their product experience. That's about me. If we go on to slide number next slide, Aniket probably can share a little bit more about himself.
Yeah, sure. Thank you. Thank you everyone for taking out time and joining the discussion. So yeah, my name is Aniket. I have around 12 plus years of experience in product management. Before that, I was a data scientist. I have experience in working at organizations like PayPal, Fidelity Investments, and Genpact. Genpact was the first company where I started my career in the data science field. And the current work that I'm doing, I'm working as a principal product manager with ASAP. ASAP is a startup who is working on solving use cases in contact center space, leveraging GenAI. So you can see the logo here as well. So yeah, that's about me. Um, quick note. Yeah.
Thank you, Aniket. Yeah. And this was the video that I was talking about, which actually is one of the highest viewed video in my channel, and has been receiving a lot of love. So over to folks who would like to listen to this, please, I will probably also put the link to this in some time in the chat. Okay, I think we can go on to the next slide, Aniket.
Sure.
So, as I said, before we kind of get into depth of it, the Gen AI is not a hype, right? It's a reality. And I'm sure all the folks who are joining us today are kind of in some form or the other using it in their personal space or for their work. It could be for brainstorming, it could be just summarization of your documentation or some form you have probably using. And this is something which article which I read, in fact, this morning. Just look at the kind of opportunity which is there only for India as a country, sorry, in terms of these things, right? So look at the number of optimization on the working hours that it will save on a monthly basis, the optimizations that we are looking at. Just look at the kind of impact it has on different sectors, right? And these are definitely some of the highest impacted sectors, right? So this much amount of work will be automated and freed up for us to be able to do high value work. Yeah. All right. So if we go on to the next slide, while this is definitely a very interesting data point, I also want to kind of talk here about that while there is definitely a lot of use cases, what are some of the topmost use cases that companies have seen Gen AI has the highest impact? Of course, I think productivity, efficiency in various, especially things like marketing, operations. We have seen a lot of use cases around us. It definitely gives you a competitive advantage by bringing in some aspect, especially where you are facing your customers building products over there. Improved customer engagement and satisfaction. And I think chatbots are examples which have been beaten to death in the last few years, right? And definitely, as I said, faster revenue growth and increased market share are some of the things where a lot of companies are kind of exploring it, right? And Aniket, if you just double click one more, I will have one more thing. This is another aspect. In each one of them, what are some of the areas where we are seeing, right? For example, streamlining your data entry tasks, competitive advantages that you are able to now do prototyping and testing much more faster. You are able to leverage your market research by brainstorming, by scanning through various sources of data just through one chat interface, right? And personalization, recommendation, all these things goes as part of your some of the other things, right? And one interesting aspect that I want to talk about here is what you see on the left side: pioneers, fast followers, wait and watch. These are the segment of companies which are accordingly deciding how much budget do we want to invest into Gen AI, right? Some of them are being very cautious. Some of them are taking a budget from some of the other areas and making sure that they are putting enough so that they don't lose out to their competition. So, right, so pioneers are the one who are ahead of the game, followed by fast followers, and then by the wait and watch. Yeah. So that is another slicing of data which I wanted to share in the next slide. Aniket, if we can go to that, is while we are trying to adopt, what are some of the main challenges? The left side graph that you're seeing is something that came out of the HFS research. And I think many of us would be already be aware, right? I mean, data is the one of the most important aspect. And this is another area where a product manager plays a very critical role. And once you have identified a use case where GenAI can be implemented, what is the kind of data that is needed? Everything around your data management, Interestingly, lack of a structured plan. So it not only requires your engineering and product to come together, this requires your entire suite of stakeholders, your business, your leadership, everybody to come together to put together a plan and be realistic about the outcomes, right? And of course, the last one is the AI talent, right? So these have been a range of challenges, and I kind of double click that with a lot of other things. I think a lot of things which we speak around risk and responsible AI is, from all the data privacy concerns. This could be the way the output of the AI could be. How do you put the guardrails in terms of the usage of the data? A lot of those aspects are kind of covered as part of on the right side, right? And of course, the product development lifecycle also goes through a change between a traditional software product versus a Gen AI product project. So that also calls for a relook at the operating model that you have. You have now new contributors like your ML engineers, your data scientists, who are all part of this product development now, right? So this also calls for a relook at the operating model, and of course the legals, the compliances, the guardrails that needs to be put in. What are the privacy laws? All those comes into this aspect. And I think another slide that I have, if I'm not wrong, yes. What are some of the risks once you kind of put your product out there? And what are some of the risks that the companies have seen is inaccuracies, intellectual privacy, IP infringement, cyber security, right? And and those are some of the aspects actually what Aniket and I also spoke about in our previous webinar, that how as a product manager I can be looking at that the outcome which is inaccurate, it is actually not a bug, right? Because in a AI product, you don't have a very deterministic model. It is a very stochastic model. That means it has to learn more. It gives an output, then you give it a feedback saying that this needs to be optimized, this is not right, this is right, and based on that it learns. So how do you handle those kind of inaccuracies? What could be some of the key metrics? Those are some things that we speak about in the last webinar. So kind of just wanted to give a lay of the land that not everything is very hunky dory with Gen AI. While it is a great start, we also need to be aware of the areas where we could get some challenges and how do we mitigate that. Yeah, so those are some aspects that I wanted to kind of touch upon. And if we go further, Aniket, yes, over to the big piece for today's session, where Aniket will take us through in detail on this use case. Over to you, Aniket.
Yeah, thank you, Malti. Apologies, first of all, I have a little sore throat, so you might not be, the voice might look a little heavier. It's not a modulation, it's happening by nature. So, so sorry for that. But let me know if anything is not explained clearly. You can always put in a comment, and then I'll rephrase, or I'll talk about that again. So this is the outline. So let's talk about the problem
Before we
first.
start,
Yeah.
sorry, just one thing. Please keep putting your questions in the comment section. And after Aniket has finished his part, I can take up the questions. Sorry, Aniket, go ahead.
No, no, go ahead. Okay, sure. So yeah, so basically the idea is to talk about like what is the problem statement. Especially we are focusing today on the fintech world, taking the experience from PayPal and Genpact primarily, and how the idea is, as Malti already mentioned, that how this problem of risk versus fraud is has been handled in the past versus now how GenAI can help to solve this problem, right? And what are the benefits of using Gen AI. And then we'll also talk about ROI and the next steps, like how ROI can be generated using Gen AI over traditional techniques that so far we have been using. You must have heard a lot of terms. So let's get into the details of those terms in risk world, in fraud detection, or fintech world. And then what are the next opportunities which Gen AI can solve? Again, broadly, we'll talk about. The session is not meant to be technical. We are not going to cover any kind of code. It's just that the idea is to talk about from a product management perspective. Let's say you are an AI product manager, you join a company, how to look at the problem from ML perspective. Let's say you join a fintech firm, So then what are the components of this problem statement of detecting fraud using ML? There can be, you can find in many companies, many fintech world, people are like started adopting Gen AI, but still there are a lot of problems are being solved using traditional ML techniques. So we'll talk about, that's why that part has to be covered, so that you guys are aware of that in case if you're not. And then how Gen AI can improve the existing processes and benefit the organization, right? So, what is a fraud? In a very simple language, a fraud is any unlawful activity which causes a financial amount to a victim, right? Loss, financial amount loss to a victim, right? The amount can be zero, from like starting from greater than zero to any X amount, right? A fraud is a fraud. It will, so the machines don't, there can be rules based on the amount, but the machine don't discriminate based on the amount, in the sense that even if it's a $1 fraud, it is a fraud, right? And the total volume of these frauds globally in 2023 has crossed $1 trillion, which is one third of Indian economy, you can say Indian GDP, right? So it's a huge industry to focus on in terms of financial amount. Banks, fintechs, financial services institutions, investment banks, all these organizations come in this, or actually fall in this, risk or fraud detection, prevention methods, or technology, right? So what are the type of financial frauds? There are many, so we can't cover all of them, but we'll be talking about a few of them here, which you can see. There's a credit card fraud, fraudulent charities, return fraud, chargeback frauds. So especially because coming from, let's say, PayPal's background, we have PayPal is a payments company, so we have like payments fraud happening. Like we have seen that how risk teams are working in PayPal to detect those frauds. Like you're sending money from X person to Y person, what are the levers where the frauds can happen, and how do we build better algorithms to detect them, right? So there are list of frauds, you can check online, it's available, all the details, definitions of them. Let's not cover here, but anyone has any question, please ask on this. Okay, so let's start from the history. So how traditional ML has been solving this problem, right? So um, if I start our journey from, let's say, maybe 1990s, where the banking services, financial services started reaching out to consumers, right? Where banks, like people used to deposit the money through the banks, and before that also. But basically, if you look at the pre-internet era, frauds, there were common, there are few common types of frauds, where like accounting frauds used to happen because the internet was not there, so online transactions were not happening, but still fraud used to happen. People like stock market frauds were there, accounting frauds were there, investment management frauds were there, mortgages frauds were there, because there was no mechanism or verification process available where these frauds used to happen, right? So and after 2000 .com bubble and all, internet, like post internet came, there are online or emergence of online transactions started happening. And then US, especially the developed side of the countries, started facing this transactional fraud as well, right? It was a start. So companies, especially US banks, started facing credit card frauds, payments frauds, in their accounts, right? You can see the number, like in 2004, US faced $3.2 billion frauds in the credit card category only, right? So and what were the measures? So then, because frauds have been detected, there was no machine learning or AI used to be there. So then what was the measures, what were the measures to solve those kind of problems? Was, let's say example, maybe you are adding a amount based flagging somewhere in the rule engine. Maybe the you have rule based approach with pre-configured rules of talking about, okay, if the transaction coming from X place to Y place, and then how do you detect that? Just block the transactions. Or maybe what used to happen is that mostly these kind of fraud detections or measures were implemented after the transactions already happened. So you had a detection mechanism, but the mechanism was not working real time, which means at the time the fraud was happening, there was no way to detect the fraud. It was not a real time detection. It was always post activity happened, you are detecting the fraud. Okay, this activity was fraud or not, and then you have a recovery process. You follow the, whatever criminal actions against to be followed. Okay, I mean, whoever is the crime master in that. So then what was the, if I look at the structure or the architecture of that, this is how, let's say, the mechanism would have worked, right? For example, there was a log event management, which is your data, right? So computers were used, but then there was no real time detection was there. What you're measuring is you're loading historical data, historical logs of those transactions. On top of it, you were building a logic, which were rules, pre-configured rules. These rules could be based on, as I mentioned already, that amount based rules, or maybe some other kind of location, country, etc. kind of rules were there. You were applying these rules. And then what happened is, whenever the rule detects anything, you were manually reviewing that, whether this activity is a suspicious activity or not. If yes, you flag yes. If no, then you don't flag it as a risk, risk transactions or risk category. Then accordingly, you take the action on the criminal, right? On the person who has done the crime. So it's always, if you look at it, there was no real time mechanism here. Mostly the system was an offline system which was detecting the frauds happening after the activity. Okay. So, and then if I look now talk about how the organizations were set up. So many, there was no software as such, like the way softwares are coming. So which means there was no product to detect the fraud as such. These organizations, where these banks, financial management institutions, they were only building the teams. Those teams role were to implement these kind of rules, to detect the mechanism. They had to maybe apply the rules, so they were creating the rules primarily, and then implementing those rules somewhere in the system, right? So there was data analytics was there, in terms of like how do you detect the data and all. Because of this, as I mentioned, the first step is log event management. You were detecting these pre-configured rules, these teams were building those rules. But again, it's a very limited, it was a very limited industry that time. It is difficult to catch up the fraud after the fraud has happened, because there are so many complications are there, right? So then the organization were designed were like, there was a team who were working on these kind of rule engines to implement those rules in the system, so that you can detect the frauds after the fraud has happened. Okay. So then the system evolved. We have now, let's say, after 2004, 2005, primarily different types of fraud started happening. Cyber fraud was the one, because we had internet available, right? A lot of people using the internet to do a lot of other activities in terms of cyber crime started happening. The phishing, the identity theft has started happening, right? Credit card fraud, as I already mentioned in the previous slides, that credit card fraud was pretty significant, like industry that started emerging. Like people started doing a lot of frauds on credit cards, payments, right? So payments fraud, you can see in the last, like this activity got surged because you had an online mechanism where you're sending money from X person to Y, and then there was no or very limited checks. You can detect these again payments, track these payments post the payment has already happened. Okay, so there are different kinds of fraud started happening in the risk 2.0. And then what are the measures that started developing by the organizations? So this time ML or data analytics started emerging. So data analytics, as I said already, was like slightly a small part of data handling, data processing was there in the risk 1.0. But there were a lot of organizations, regulatory compliance organizations started coming in. They mandated the banks, the financial institution, to store the data properly. And based on that, because once the data is available, you can build the models on top of the data, right? So because the machine learning models, the AI has a dependency on the data availability. So then, because the data was available, some regulatory compliance pressure, then the organization started building teams which were dedicated towards building algorithms which can detect the machine learning, which can detect the frauds using machine learning techniques. So then you had many approaches. I'll talk about that in the next slide. So you had many approaches available. Whichever has the highest accuracy or higher accuracy, we were using that in the machine learning model development process and then deployment process, and on along with the rules as well, we were implementing these models. And then not only that, there was always a monitoring process also, which means that whenever something unusual happens, you can always track it. There's a behavioral pattern detection techniques like anomaly detection has also started emerging. So there were a couple of techniques. These are all these three techniques. If you compare from risk 1.0 to 2.0, all these techniques are new, right? Because these were not existent because there was no data as such, right? So then how these data science teams using these kind of techniques, using or to build or to develop these ml model. So because the data started like data availability was there, there are a lot of steps that you need to follow to build these kind of models. So here what I'm trying to showcase is what are the tools and techniques available to the to a data scientist or to the data science team they can leverage. Like there is a data collection process in which you collect the data from your databases wherever the data is stored. Then you have tools like Python and R and other kind of rapid miner kind of tools which you use to clean and process the data. Then there is a data exploration exercise. You can do insights generation, what happened. Anomaly is also a part of that. Then you do data analysis, which is basically sharing the insight with the business, and after that you build machine learning models. So there is a process that data science team follows, and then they build these kind of ml models. So I'll talk about the architecture now, like how these in the risk 2.0 especially. I mentioned specifically real time here because now you have a mechanism in which you use to deploy these models. So there are two parts of an ml model. An AI product manager has to understand these two differences. One, there is a data, which I talked about the tool and technique, right? There is a data cleaning plus model building process where data science teams are responsible for building these models leveraging the data that is existent. Then there is a engineering team, which is the ml engineering team, who is responsible for deploying these integrations, right? A model to detect a fraud real time, you'd have to um, basically implement these or deploy these models in some architecture. That architecture can be anything, like for example you're using cloud, so then it can be a cloud architecture. Here what I'm trying to simplify the processes, because just to make you guys understand more, that let's say there is a data collection process where you are accessing the data from the apis, from the logs, historical information. There is a data cleaning processing, which was the previous slide that I was talking about. Then you have a model development process, which is basically building the model, like logistic regression. I don't know if you've heard the name of that. Ensemble learning, neural networks came that time, that where the data science teams started developing these kind of techniques, and whichever has the highest accuracy, we use that model as the final model for deployment. Then the deployment start. You have an engine where you deploy the model. Every company might have their own engines. If you want to refer more technically, like how the architecture work, you can check Uber, you can check um, um, other company with, like especially in the payments and fintech world, like how they are detecting what kind of architecture they use to detect the fraud, right? But the idea is that you deploy these models, whichever data science team has built. The engineering team, product manager works very closely in this whole mechanisms, in the sense that like what is the expectation on the accuracy. It's not about what model are we building, but the model is deployable or not. What is the latency of the models? What is the expectation from the model, like when the model goes for deployment? So these kind of requirements, the product manager, the AI product manager, has to share with the engineering as well as data science team, and then communicate to the maybe the account management team or the sales team, whoever he or she is working with. But then you have deployment stage. Then you have rules engine, which is again, there are companies who actually work on the rules as well on top of the model, because there can be few regulatory compliance based rules. This is very important because model can detect anything which is suspicious. Then whether that suspicious is actually suspicious based on the regulation and compliance or not, there can be some definition changes there. You add those things post building the model as a rule. And then you have a response, which basically now model plus rules give you a response which is real time automated, which means the flag part. Like whether, let's say example of a payment transaction, we collect the data, we pre-process the data. Now transaction level, let's say a transaction is happening, transaction is coming to a company's engine. The engine runs for the data pre-processing step. Then there is a model which is deployed. Now model will generate the inference, whether this was a based on the model prediction. Basically inference is prediction only. So you make a prediction, apply the rule on top of the prediction, now generate the response whether this was a fraud or not. If this was a fraud, It goes into detection, generate the alert, and score the transaction, share it back with the whatever machine who is like front end that is being worked upon. Or also in parallel, if there is a feedback, let's say some suspicious activity happened, you generate that data as a part of feedback loop, which means that now you have one more transaction in the database, which can actually make your training data or model richer. Because the more data, more information you gather about the transactions, the more rich model you tend to make. But depends the quality data or not, right? So this is a typical architecture of machine learning models or AI/ML models until the Gen AI came. I hope this was clarity. This was clear to everyone. And please ask any questions if you guys have. Hopefully, I was able to justify the architecture and the definition. Those are then what is risk 3.0? Now this is very important. I have taken only AWS example here. Again, it's a very high level. Things can be more architecturally technical. So we are not going to details of that. But what I'm trying to say here is that um, risk 3.0 is after especially 2022 onwards, when the Gen AI model actually came to us or available to us as an API, or as a basically pre-trained model. So if you think of Gen AI, so primarily when ChatGPT launched, it was November 2022, I guess. So OpenAI, the company who launched ChatGPT, their model name was GPT 3.5. Currently, the latest model they launched is GPT 4.0, which is omni-channel, which means voice and text data both. But so basically, that OpenAI launched this GPT 3.5 models, which was a closed source model. So when I say closed source, means that that model is only available via API. You cannot access the code of GPT 3.5. That is not publicly available. It's called closed source model, right? So versus you have some pre-trained models, which are, especially if you've heard the names of Mistral, Llama, which is Facebook's um, 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 status model, right? Which is the state of the art model. Llama 3.01 is the latest model that they launched with, I think, 450 billion parameters. So these models are called open source models. What do you mean by open source models? You can actually access the code of these models. They are made public, which means that you can go to, let's say, for example, you're going Hugging Face, and you can download the code of these models. You can use these models, deploy in your own environment, right? Which means that you can train these models. So then we have two types of models, open source versus closed source. I am taking the example of an open source implementation here. Like, for example, a company who's building a software, how that will use one of the model, let's say here, which I'm talking about, um, to build a product. That product will detect the fraud, or build a software. That software will detect the fraud, right? So then you have an open source models, you have closed source models. Open source models means you can access the codes for them, you can implement in your own environment. If you want to train the models, you can do that. Then you have a API based model. Now how OpenAI will be implemented here is, you cannot train those models. You can always call an API, which means, let's say, what happens is, if you want to use GPT 3.5 for your, just one second, sorry, GPT 3.5 for your use case, what you can do is, you can actually send the transaction to OpenAI cloud. The transaction will be taken by OpenAI API, and then the model will make the prediction, and send you back the response. So then here your role is, you don't need anything, you need a machine. That machine will call the API. That API will predict whether this transaction is a fraud transaction or not, and then send you the response, right? So you get the response, and then you take the necessary action that is required to be taken. But on the other hand, let's say you're building a product with which is the model that you're building, or implementing the fraud detection models in your organization using generative AI. Then how can you do that? So as a product manager, you need to understand the architecture. Again, we don't need to understand the models details, how these technically implemented and all, but overall architecture we need to understand, right? So then you can look at his, so there are a lot of images available. I'll just talk about very quickly. I've taken AWS example, that's easier to understand. You can always look at Google Cloud as well as you can also look at Azure. All these three hyperscaler companies have their own environments, which can provide you state of the art models available. You just call them. So then what happens is that, let's take an Amazon Bedrock example. Amazon Bedrock, if you check it, It's basically a platform that gives you all these GenAI open source models already pre-trained available for you, which means there's an environment in which you just have to call these models. So there are two ways to call these models. Um, One way is zero shot approach. What is zero shot approach? Zero shot approach means that you just call the model. You These are all pre-trained models. Pre-trained model means that in the when these models were built, they use some historical data, right? These So the parameters that I talked about, like 70 billion parameters, 50 billion parameters, these parameters are the weights, or they are the, you can say, predictors technically. So which means that what these models were trained upon historical data, and then these weights were saved. So when you use zero shot means you are not passing your data for training. You're just calling them, in the sense that you're not training these model for your domain specific data. You're just calling them as it is. They are available, and they give you the prediction, right? So then what you do is, as a user, you, let's say you have some data that is getting passed. So you can see query one, step one here, which is your, let's say you're sending the transaction or the query, that which basically a prompt. You're sending the prompt, then query here, and then step number three is basically that the transaction is stored some data storage here, which is, let's say for example, in Amazon, S3 bucket storage is the main database where the data gets stored. That data then pass to the, you can see here, filter relevant data and query augmentation. Whatever prompt on top of the data you need to apply, you apply there, and then send that prompt, you can see query plus relevant data plus prompt, to the model. Now these models work on prompts. These models don't work on technically like the training data as such. Like you don't have to pass the training data whole thing. These basically you just have to pass the prompt. Once you pass the prompt, okay, can you tell me for this transaction whether this transaction is a fraud or not? Let's say this prompt that you send. Once you send that prompt, you get the response. Whatever business logic that you have on top of these responses that you got from the model, you can apply that. But the idea is, once you have the response, you send back the response. Let's say here the chatbot example is given. Whatever is your UI, you can actually tell, okay, whether this transaction is actually a fraud transaction or not. And then user or consumers use that particular information, whatever the response was, right? So this is one of the way to implement the, let's say, a Gen AI or generative AI solution in the fraud detection in the AWS environment, for example, right? So any technical definitions, any technical term that you want to understand, you can please pass on the comments. I'll answer them towards the end. We can, if this is, you want to, let's say, any questions, I can come back to the slide later. But right now, I'll probably move to the next slide. Okay, so now what is the benefit of using the Gen AI over the traditional ML methods, right? So if you remember the slide, the risk 2.0, there were a couple of limitations were there, right? One limitation was the that let's say the data limitation. So the data limitation is basically meaning that you don't have sufficient data to train the model. As I already said, that machine learning models or the deep learning models, they tend to become rich as you pass more and more data. But if you don't have the data available, or necessary information available, you won't be able to train the model. So which means, let's say today you want to build a fraud detection engine. That engine will work only if you have, let's say, last 3 months of historical information, last 3 months of data, because then you have to follow the whole process, right? And then you'll be able to build the model. If that model is not the data is not available, then you won't be able to build the model. With Gen AI, the problem can be solved. How? You have one part is zero shot, which basically meaning that you're not even passing your, you don't have to train any models. These models are pre-trained. You can just start sending your transactions from day zero and implement that. That's that's one. So second thing is that you can actually generate synthetic data. You can actually pass a prompt to these GPT 3.5, Llama, and let's say other GPT-4 models, which basically that, okay, this is my example, this is my sample data that I'm using. Can you generate more data similar to this data, which I can use for the model training? What these models or generative AI will do is, these models will do, they will generate or mimic your the data that you passed, which means that they'll be not like duplicating the data, but they'll be generating similar information which looks similar in terms of the features of the data to you. And then you can generate more and more data, so that what will happen is, now from day zero you will have significant information to train your model. That model can be less accurate, but at least you have you basically have a way to start with, right? So then you can, so which means that data dependency is reduced significantly. You can start implementing the fraud detection engines from day zero. Now the benefit of the organization is what? Think about this, right? You don't have a way to detect the fraud, and let's say frauds keep happening for the next 2 months, let's say, until you get the data. You can imagine the amount you can save from day zero. Models can be less accurate, people can question that, that's a different story. But in general, let's say 50% of the frauds we are able to stop, it's a savings of 50%, right? That part was not available in the traditional ML. Now you're solving with generative AI. The second is data imbalance. When we do the data pre-processing, when I talked about the tools and techniques slide, the data pre-processing, data cleaning, the data science team faces a lot of challenges, especially the data imbalance problem. What is the data imbalance problem? Think of this. Let's say 100 transactions happen in a day, right? These frauds happen rarely, because these frauds are also very less successful in their attempts. They do 1,000 attempts and they get only, like, let's say once they get successful. So then what is the ratio? 1/1,000 transactions are fraud transactions. So in that scenario, when you build a model, traditional ML model, the ML model, as I said, the more data you have, they get richer. So which means that, um, let's say you have 999 versus 1 ratio scenario, then model will try to mimic more on the 999 transactions versus one transaction, because it only has one transaction. So which means what will happen? You will generate a lot of false negatives. So in the sense that even if the transaction might be a fraud, but you're not able to detect it because your model is biased towards those 999 observations or transactions. So to handle that, there is a way in generative AI. What is the way? You can generate more data, which means fraud transactions. You give the description with a prompt. With the prompt, you give the description that this is the fraud transaction. Can you generate more transactions similar to this? I need to balance my data. Then GenAI can generate again data for you and send it to you, and then you can implement it. Okay. Anomaly detection. The other part is, which is basically meaning that any kind of a normal behavior in the ML will give only the predictions to only those transactions which has learned well. It's like referring from a book, right? So if you have read a book thoroughly, then you'll be able to answer the questions from the book. Let's say something comes up out of the book, but the concept could be similar, you might not be able to answer that well. So this can be handled via GenAI. GenAI, if you write a prompt in future, if you detect anything suspicious, flag that. That cannot happen in the traditional ML, which means that you can build, even if the data was not there, you can build an engine which can detect any kind of abnormal behavior pattern in the transactions, and that can be flagged immediately, right? The other part is feedback loops, which is now real time feedback, right? So think about this. You have a UI. The moment you flag it, it goes automatically in the prompt. Your prompt is dynamic. And then which means that your prompt, you can customize your prompt, and prompt customization is a very easy exercise. You can always do it. You can daily do it, for example. So then the implementation of the feedback is much faster in Gen AI than traditional ML. Yeah. Okay, so continuing on that, so what is the benefit to the organization? Especially, so the previous benefits were mainly from the modeling perspective, from the implementation perspective. Organization level, a couple of them I've listed here, which I think Malti talked about in the beginning only, so I'll not go into details of this one, but operational efficiency, right? The example that I gave. Now you can implement fraud detection engine from day zero, which means, let's say, 3 months, your data scientist would have waited on a particular data availability. Now you are starting with day zero. And even if you're achieving 50% of the results, it's still better than zero results. So think about it, the 3 months time you saved, your data scientist time is saved. Second, productivity. We have been talking about automation. Many of these rules, of course, which are monotonous in nature, any prompt, for example, now there is an agent building exercise going on, so you can design a prompt by using these generative AI models only. You can implement them, and then this improves the automation, which means that the data scientist now, let's say, if the task of a data scientist 70% part on model building versus 30% part of the other work, now The data scientist role will be 70% of the other work, which is, let's say, business communication, solving different kind of problems, new problems, versus 30% of the work will be on the data science model, because now that work will be taken care by the automated Gen AI solutions, right? Time to value, as I said. Now think about software companies. Your software will be like ready from day zero, so the companies can start seeing the values on day zero, right? You can do a POC from day zero. Companies see the values, the ROC. Let's say I'm buying a software of the AI software, so I can actually evaluate this from the first day onwards, and I can see whether I want to buy it or not, whether this is helpful or not, right? And this process is being further improvised. Things have been happening at a rapid scale to generate these values of these kind of softwares products, leveraging Gen AI. Scalable solution. If I talk about the Amazon architecture, there's no limit to storage of the data. The technologies, the storing, cloud storage, and all are much cheaper. You can actually, and the more data you have, the more anomalous transactions you can detect. You have a scalable engine to perform these kind of tasks. So which means that you achieve scalability again, through using generative AI, which was not possible in traditional ML. What is next? There are new types of frauds coming every day, right? We see that different kind of frauds. Example, these WhatsApp fraud, these are happening. Still, WhatsApp is not able to implement any kind of technology behind these WhatsApps that come to us. These calls, voice modulation, people start you know doing that. So these kind of frauds, like how can you detect that within a platform? Like tomorrow, example, WhatsApp implements a multi-model fraud detection engine, which basically meaning that any kind of activity happen through any channel, through diverse data sources, it can detect that. Think about that, that it has an engine which automatically detects any kind of fraud message comes to you, or unknown IP or something that comes to you, it can detect that. And then these frauds can be reduced significantly, which are recently happening. The technology is working, or basically organizations are working to detect these things, because these are like these things are happening pretty rapidly in the recent times. But you can, this is the next problem that can be solved. And especially, I'll talk about these face detection, deep fakes and all. You must have heard about models like GANs, which is generational adversarial network, um, and using the multi-model, which is vision plus the text, right? So right now GPT 3.5 is only text model, but their model is Sora, which is vision plus, which is a vision model. So there are a couple of models are being built by Google, is GPT, the OpenAI companies. They are using both the text data plus the video, the image data, to process the information, so that they can detect fraud or whatever activity is required, they do that. So these kind of next set of challenges, only Gen AI can solve. There is no other technology we can think of can solve this. I mean, basically it has to be a technology which is should be using leverage, Gen AI, right? These multi models, these vision based models can detect any kind of frauds in future. Yeah, I think that's it. We are, I think, on time. I think I can stop sharing if we can take questions.
Yeah, I think, thank you, Aniket. I think that was a great explanation, going very, very deep in terms of the fraud detection use case. I think we had a little bit of confusion because there was earlier another event which was created, and we were not able to map it up. So people were waiting on the other call. But folks who were able to join us, please let us know if there are questions that I or Aniket can answer. Please put it in the chat.
But ultimately, people were able to join this, right? Malti, are you saying, or no? They had a, still they were like
Yeah,
toward.
I'm also trying to figure it out since this
Yeah.
is the first LinkedIn live that I'm also doing. So yeah, because when I created it with StreamYard, got another link, but I thought that with the profile it just goes live. Yeah, thank you, Tanu. Nitika, folks, any questions that you may have, please feel free to post it in the comments. Are you able to see the comments as well, Aniket?
Yeah, I can see, but I think no questions has come yet, I guess.
No, I don't see any questions yet. We'll wait for a few minutes more.
Sure.
Meanwhile, is there anything, Aniket, that you're working on at ASAP?
Yeah.
Any use cases that you want to kind of talk about from there?
Yeah, sure. I can maybe very quickly share my screen again and talk about
Uh-huh.
ASAP. So I would love to talk about ASAP always. Um, so ASAP, as I was mentioning, is basically a startup who solves the contact center. So basically, is built for contact center solutions using GenAI's techniques. So one of the product that ASAP is selling, or the primary product, is generative agent, which is the you can think of as this is a voice bot, um, which requires no humans in the, like, basically whenever you talk to an agent, you're not talking to an agent, you're talking to a bot. And that bot is designed in such a way it can solve for an organization, solve all these use cases on its own without depending on the human. There is a concept of human in the loop here, which basically whenever whenever a problem is complex, then it refers to the human in the back. But it's fully automated AI voice bot, where you can talk to the bot and solve any kind of problem. So, for example, ASAP has customers, so which is enterprise customers. These enterprise customers call centers they have. We implemented the generative agent in those contact centers, and now their customers, when they call these contact centers to an agent, they talk to an agent, they're talking to generative agent. So the idea is to fully automate the agent experience. The other two product which I handle primarily is called auto summary and auto transcribe. So what is auto summary is, you can look at the product name here. It is primarily, it does two three things. One, it generates a summary of the call. So a lot of time, if you look at the task or the workflow of an agent who is talking to a customer, does multitasking a lot of times, which means that whenever he or she is talking to a customer, he has to take the notes, write the summary of the call, fill up a form. These kind of activity the agent has to do either during the conversation or post the conversation, which means the conversation has ended, but then agent has to fill up these kind of tasks, which is we call disposition notes, or the task at hand. What auto summary does is it leverages GenAI, the latest GenAI. We have in-house GenAIs also, as well as we use GPTs as well. But the idea is that leveraging these, we generate these kind of the summaries, the data, and the intent of the call on its own, which means now agent doesn't have to do these, or doesn't have to write these notes, doesn't have to write the summary during the call or post call.
Oh,
So then, so you save a lot of time. Generally, an agent takes 2 to 3 minutes after the call to finish these disposition notes. And now, because the notes are upfront available, and the second thing is live available. Like, even let's say an agent is not able to understand some task or some conversations, he can always refer to the summary that is being generated, to the transcript that is being generated, real time. And then you save these 2 3 minutes per agent. Um, every call. Imagine now the number. So let's say there are 500 calls coming in a day, or 5,000 calls coming. The larger the organization is, the more number of calls you will receive, the bigger data, call center data, that your call center, the bigger call center you have to build. So then you have large number of calls coming on a daily basis. Per agent, you are saving 2 minutes of time, which means, let's say an agent used to take 100 calls in a day. Now the agent can take 120 calls in a day, right?
right.
So you
Huge
save.
amount of work.
That's the ROI part, right? So, and that's the value of the product. So this is end to end automated. No manual step is taken. It's a complete integration, which I talked about in the slides as well. GenAI integration, where the notes, everything is being generated via GenAI model.
Awesome.
So far, the feedback of this product has been very good. People are liking this product, interested in this product. Lot of queries we receive on a daily basis, that okay, how this product works. And many, as you mentioned in the first or two slides, I think there were three segments of customers: the innovators, the fast followers, and then laggards, right? So especially the
Correct.
queries. So far, the GenAI is at somewhere in the middle, but I think we'll soon shift the
So
other set of customers also. Yeah.
yeah, there is one question probably Aniket that you might want to take up. First of all, thank you for sharing us with what ASAP does.
Yeah.
So Arun is asking, can you talk about the Amazon Bedrock pre-built models?
Yeah, you can check the Amazon Bedrock website as well. So Amazon Bedrock basically is a platform where see these are, so if you, I don't know if you have heard this AWS SageMaker, Bedrock. These are all platforms which provide you ML models inbuilt. So what you have to do is you just integrate with them. Integrate in the sense that there is a process in which engineering like starts sending the data to these models or prompts, and then your data gets stored in AWS cloud, which there's three bucket that I was talking about, and then from there you have the prompts designed, and these let's say you implemented probably Mistral model. So then these models are called using the prompt that you have. So it provides your platform to implement these models in your environment, right? So there are two ways, as I mentioned. Zero shot, which means that you are not training them, you're just calling them. The second is you can also fine tune them, which means that is slightly different process. So that you have to download the code of the model and train it for your domain data specifically, and then generate the responses or predictions, they implement it basically to your environment.
Okay, all right. Arun, do you have a follow-up question?
So you can check the Amazon Bedrock. Yeah, there are a couple of models available. Yeah, I hope that answers the question, Arun. Yeah,
In
I'll
fact,
share the link
In
as
fact,
well.
one of the things, in one of my podcast episode, Aniket, I was talking to one of the uh, uh, guests, and they were saying that in the coming years, actually, while there has been a lot of focus on the application layer of side of things, but there is a huge,
Yes.
gap that you have in the overall stack. The entire AI stack, where it could be libraries, it could be frameworks, it could be on the infra side of things
Yeah.
where a lot of startups will actually have the opportunity to come up with products.
Yeah, we covered this in our, if you remember, we covered this in our AI product management session as well, right? So the application, the infrastructure layer. So the
Correct.
application layer is growing. So where every problem, not every problem, like most of the problems which are solvable are being solved now using generative AI. So wherever it is can be applied, companies are coming up with software, the product, especially these startups are coming up. They're leveraging GenAI, of course. Yeah.
Correct. Exactly. Yeah, that's right. So yeah, I mean, I do not see any other questions, but this was a great summary and a lot of detailed view, Aniket. Thank you for walking us through with a lot of details. And I'm sorry, a lot of folks had actually registered in the other event. So
Oh,
I think the good part is that this entire thing is recorded, and I will post this again. So folks can also find this offline, and always feel free to reach out to me or Aniket if you have any questions. Yes, this video will be available on the LinkedIn. This thing, Arun, I will reshare it as a post, so you should have it access also to offline.
okay.
All right. Yes. Thank you so much again, Aniket. This was a fantastic session, and thank you, folks. And again, apologies for the confusion on the event link. Hopefully, we have our lessons learned today and be very more careful in the future. Thank you.
Thank you. Bye.